Assalamualaikum warahmatullahi wabarakatuh, and hi, this is the second example in the textbook. Compute f.dr for C, where C is the line segment. So this question already told you that you have a line segment from point 420 to 463, and F, your vector field, is this one. So what is the difference between example 2.27 and 2.27? So the difference is the previous question give you the specific R. Okay, what is the X, Y, and Z in order to get the parametric equation. But for the second one, the question does not mention what is your X, Y, and Z. But this question is already told you that you have a line segment. So, sorry, my son ni memang suka buat bising. Okay, so next, the first step is you know that you have a line segment. Probably you want to sketch the points or the curve from point 4 to 0 here. Okay, 2.463. Okay, over the vector field F is given by Z negative Y X. Alright, so now the first thing is we need to find out what is our RT. Okay, go back to our question. The question told you that you have a line segment, so that use the formula of parametric equation for the line segment here. 1 minus T R0 plus T R1. So what is R0? R0 is the initial point, which is 420. Okay, and then plus T R1. So what is R1? R1 is the destination point, which is 463. So that you will have your R equals to 4, 2 plus 40, and 3T. Okay, so what is 4, 2 plus T, and 3T? Okay, so 4, 2 plus 40, and 3T means that this is your X, this is your Y, and this is your Z. Okay, X of T is 4, your Y of T is 2 plus 40, your Z of T is 3T. So that is the meaning of your RT. Okay, so what is the importance of knowing that you have this is your X, this is your Y, and this is your Z? This is important because we want to substitute what is your F. Okay, we need to transform X, Y, Z in F into the form of T only. So initially you have Z, negative Y, and X. So that what is Z just now? So you have 3T, so put 3T. And then you have negative Y. So what is negative Y? So you have negative 2 minus 40. Okay, and then you have X here. So what is X? X is 4. So this is your F. So now we want to integrate, or we want to compute the work done, total work done from point A to point B. Okay, along the curve of F dot R prime T dt. F is this one, dot with your R prime T. This is your R. This is our R. We need to find the first derivative of R and then put it here. Okay, so integrate with respect to T. And do not forget that we are dealing with the dot product. At the end of your solution, you have a scalar only. Okay, so the next target is we want to solve for what are the limits. Okay, the same thing as we have discussed just now, or previously I told you that if you are dealing with the line integral parametric equation for the line segment, if you are dealing with the line segment parametric equation, usually the points from A to B is from 0 to 1. Okay, the point of T, because you integrate with respect to T. Okay, so let's discuss or verify whether our hypothesis our statement is true or not. Okay, so if we start from the initial point is 420. Okay, and then our R is given by 4, 2 plus T, and 3T. Okay, what is the value of t in such a way that you can find 4 equals to 4? Oh, nothing. Okay, so we cannot show this one, so we assume that t equals to, you don't have t here. Okay, and then we go to 2 plus 40. What is the value of t in such a way that you will get 2 here? You will get 2. So probably t equals to 0. When t equals to 0, so you have 2. So this is 2. This is correct. And then the next point is you have 3t. What is the possible value of t in such a way that you have 0? So the answer is 0. So the point is from 0 to what? To what point? Okay, go to the destination point 463. So 463, what is the possible value of t in such a way that 4 equals to 4? I think we cannot compare this one. So next is 2 plus 40. What is the possible value of t in such a way that 2 plus 40 equals to 6? So the answer is 1. The next thing is 3t. What is the possible value of t in such a way that 3t equals to 3? So your t obviously equals to 1. So our statement is true. Okay, f dot r prime t dt, and we are evaluated along the curve. When we parameterize the equation, we actually evaluate along the curve from 0 to 1. Okay, firstly we have 420 to 463. So that is the point of x, y, and z. When we parameterize, we want to parameterize the equation in t, and the same thing will go to our point of t here. Alright, so next, find the work done if F. So F is given, is the force field on the particle that move in the counterclockwise. Counterclockwise is counterclockwise, okay, around the circle. If this question does not mention this is a circle, you actually know that this is a circle because this is in the form of x square plus y square equals to r square, where your r equals to 1 and z equals to 0. So of course lah, because circle in two-dimensional space, you don't have the height, so the height is 0, so that you have a circle. If you have a height of z, means that you have a cylinder. Okay, from point 100 to point 010. Okay, so that you have this one. Okay, so your curve C is a circle. When you have a circle, your RT just now is XT, YT, ZT. Since you are dealing with circle, so that Z equals to 0. So what is your X and Y? Your X and Y is R cos T. What is your Y? R sin T. And what is your Z? No height. So that Z equals to 0. So this is your RT. Find the first derivative of RT because we want to substitute into the formula of line integral. So that this is your X, this is your Y. Okay. And this is your Z. When you are given the F just now is 9xy 3y square 4z, so that you need to multiply lah. Okay, so you need to multiply. Okay, so what is 9xy? So 9xy is 9. What is your x? R cos t, R sin t. So note that after this we want to integrate. Okay, f dot r prime t dt, okay, so that the only one variable is only t. So you can substitute whatever value of your r according to your equation of a circle. Since your equation of a circle is x square plus y square equals to 1, where your r square equals to 1, so your r equals to 1, so r here can be substituted by 1. So you have x equals to cos t, y equals to sin t. I hope that you understand what I mean here. Okay, so that go back to here. So 9xy, which means that you have 9 cos t and sin t. Okay, comma. And then you have 3y square. 3y square is 3 sin square t, comma. And then z is 0 lah. For z is 0. So that is your f. F dot r prime t dt. Okay. So now we want to know what is the limit from point here to point here. Initially, the point is from 100 here to 010. Since now we have a circle, so what we need to do here is, in order to put the limit of t, since now we have a circle, so that you need to substitute the limit in the form of your theta here. Okay, so it is evaluated from 0 to the quarter of your first quadrant. Okay, so quarter of your first quadrant, so means that quarter of first quadrant, so at the first quadrant actually, okay, so you have to move a particle from this point to this point, which means that you have to move a particle from 0 to pi over 2. So this is the unique limit when you have a circle. So when you have a circle, please check what is the limit of your theta. Okay, so is it in the first quadrant, second quadrant, third quadrant, or fourth quadrant? Okay, fourth quadrant means that you have a full circle, which means that the limit is from 0 to pi. Sorry, 2 pi. Okay. So you can evaluate here, and then you will get -2 as the solution. Okay, and let's discuss the third example in the next video. Thank you.